In our lesson yesterday, we had a review of the measures of central tendency, and our goal today is to be able to figure out which measure of central tendency is best going to represent a set of data. The measures of central tendency that we talked about yesterday, there was the mean, okay, and remember that the mean is really the average. You're looking for the average of the data when you find the mean. Okay, there was the median. The median is the middle of your data. And then there was the mode. Okay, and the mode is the number that's most occurring. Okay, whichever number shows up the most in your list. And you can have no mode, none of the numbers can show up more than the others, or you can have more than one mode if more than one number shows up more often than the other numbers. Now, one thing that we're going to have to look for today is something that's called an outlier. An outlier is a piece of data that is extremely different than most of the data. Okay, again, an outlier is a piece of data that is extremely different than most of the data. It could be a lot lower than a lot of the data, or it can be a lot higher than a lot of the data. Okay, we call that an outlier. So in our first example, we're going to look at monthly costs of cable television, and here's our list of numbers. Okay, the first thing that I'm going to need you to do, put those numbers in order from smallest to largest. The first measure that we're going to calculate is the mean, which again is the average. So the first thing that you need to do is add up all of the numbers, and once you have that sum, you're going to divide by the number of values, which should be 8. 1, 2, 3, 4, 5, 6, 7, 8 pieces of data. Okay, so when we add up all of the different prices of the cable TV, we should come up with a number of 248 for the sum. Okay, now we're going to divide 248 by 8, and that's going to give us an answer of 31. Okay, so now the mean is 31. We need to see how does that compare to most of the data. And if you look at your list here, okay, 31 would fall right here in between 30 and 34, okay? Well, looking at the placement of where that is in the list, it appears that the mean is going to be greater than most of the data, okay? There would be 1, 2, 3, 4, 5, 6 pieces of data that are lower than the mean, and there would be 2 that are higher than the mean. So that means that the mean is greater than most of the data. We're now going to calculate the median, or the middle of the data, and we said before that there were 8 pieces of data in the list, which is an even number. And so if there's an even number of data, you're going to have 2 numbers that show up in the middle. So we're going to see if we can find, all right, 1, 2, 3, 4 times we move in, and we see right here these two 26s are going to be the median of the data. All right, so when we average these numbers together, well, they're the same number. The average of 26 and 26 is 26. Okay, so how does the median compare to our data? Well, the median is right there in the middle. Okay, so I'm going to say it's not greater than most, it's not less than most, but I'm going to say it's close to most of the data. Now we're ready to calculate the mode of the data, which again is the number or the numbers that occur most often in your list. And glancing through my numbers, okay, I can only see 115, 124, 125, 226s, 130, 134, 168. So it looks like it's going to be 26. 26 shows up twice, while all the other numbers show up only once. And again, how does the mode of 26 compare to most of the data? Well, again, it's going to fall right here somewhere in the middle, so I'm going to say it's close to most of the data. Okay, so now what we need to do is try to pick out which one of these measures, the mean, the median, or the mode, is the best measure of central tendency to represent our data. So again, we had a mean of 31, which was higher than most of the data. We had a median of 26, which was close to most of the data, and we had a mode of 26, which was close to most of the data. So in this example, we want it to be most representative, so we want something that's going to be close to most of the data. So we're going to have to eliminate the mean on this one. The mean is out because it's greater than most of the data. So that leaves the median and the mode. They were the same number, okay? But for our purposes here, we're going to say that the best measure of central tendency to describe the data is the median. Okay, and it'll become a little clearer later on in the lesson why we wouldn't say the mode, but we're going to go with the median because it was close to most of the data. Okay, and the reason why we're not going to pick the mean, again, was because it was higher than most of the data. Well, why was the median higher than most of the data? Well, if you look carefully at your list of prices, okay, they're all pretty close to each other until you get to the very end here, all right? That $68 price is twice our next highest price. So all of these are pretty close together, but then we suddenly double up to $68. This number right here is called an outlier. Okay, so the best measure of central tendency is the median because there is an outlier. There is an outlier. And again, the outlier was 68. That increases the mean. Okay, when you have an outlier that's a lot higher than most of your data, that's going to make the mean become higher than most of the data. It works the other way as well. If we had a number that was much lower than most of the data, then our mean would end up being much lower because of that outlier. So if there's an outlier, well, then we can't use the mean. So we're going to have to go with the median. So how do you choose the best measure of central tendency? Well, in the last example, we said we chose the median because there was an outlier. So we're going to choose the median when the data contains an outlier. Okay, if the data contains an outlier, the median is going to be the best measure of central tendency. What if there is no outlier in the list? Well, if there isn't an outlier that's going to affect the mean, that's when you would choose the mean. Choose the mean when the data does not contain an outlier. Okay, choose the mean if the data does not contain an outlier. If the data does contain an outlier, then we're going to use the median. And again, we're going to talk later on about when we should choose the mode. So now we're going to look at the next example. All right, these are the ages of 7 people who auditioned for a role in a play. And I first want you to calculate the mean, the median, and the mode. So we've got our numbers in order from least to greatest. Let's start by finding the mean. The first thing you're going to have to do is add up all of these numbers. Okay, and when you add all of those numbers together, you should get a sum of 119. And now we need to divide it by how many numbers there were, and we were told that there were 7 people that auditioned for the play. So we have to do 119 divided by 7, which is going to equal 17. So the mean of the data is 17. How does 17 compare to most of the data in the list? Well, 17, well, I see a 17 right there. It looks to be, I've got 3 lower than that, I've got 3 higher than that. So I'm going to say it's close to most of the data. Okay, now let's find the median. Again, the median is the middle. We know there's an odd number of pieces of data, so there's only going to be one number in the middle. So let's find that. Okay, we start at the ends, moving once, moving twice, and there it is. That 17 is going to be the median. So the middle number is 17. And again, that's going to be close to most of the data. All right, and now we need to pick out the mode. Which number or numbers show up more often than the others? And right off the bat, I can see 2 12s, but all the other numbers show up only once. So the mode of the data is going to be 12. How does 12 compare to your data? Well, it's at the very beginning. All right, there's 2 12s. Every single number after that is is higher than that. So I'm going to say that the mode 12 is less than most of the data. So which measure is the best measure to represent this data? Well, we're not going to use the mode because it's less than most. The mean and the median are close to the data, okay? And looking at my list here, I would say that these numbers are pretty close together. There doesn't seem to be one that's a lot higher or a lot lower. So I'm going to say that there isn't an outlier here. So I'm going to go with the mean. The best measure of central tendency to describe the data is the mean. And the reason why is because the data does not contain an outlier. All right, and we said before, if there is no outlier, then the mean is going to be the best measure. In the next example, we're looking at points scored by the 7th grade basketball team, okay, and that was our original list. I've already gone ahead and rearranged it from least to greatest underneath, so go ahead and pause that and do that on your paper. Okay, and now we're ready to calculate our measures of central tendency. So let's start with the mean. We add all of these numbers together. You should get a sum of 266. Divide by how many numbers there are. Count them up. I see 7 numbers in the list. 266 divided by 7 is equal to 38. How does 38 compare? Well, 38 would fall in the list right here. All right, there's going to be 5 numbers less than that, 2 more than that. So I'm going to say that this mean of 38 is greater than most of the data. Okay, the median, well, there's 7 pieces of data, so only one's going to be in the middle. All right, move in again, and I can see 35 is our median. It's the middle number, and 35 appears to be close to most of the data. Okay, the mode, what number or numbers show up more than the others? Okay, well, at the end I see 2 55s. Every other number only shows up once, so the mode is 55. And that 55 is greater than most of the data. Okay, so in this case, the best measure of central tendency, the one that was most representative, is the median. It was the only one that was close to most of the data. Why is the median the best measure? Well, again, all of these numbers are pretty close to each other until we get to the end where we see those 2 55s, which are going to be outliers. So the reason why is because the data contains outliers. If the data contains outliers, then we use the median as the best measure of central tendency. In example 5, we're looking at the favorite colors of 10 random students. Okay, and so here's our list of colors, and we need to find the measures of central tendency for these colors. So we're going to start by finding the mean, which again is the average. Well, in order to find the average, you have to add all of the colors together. Now that sounds a little funny, doesn't it? Can you add colors together and then divide by how many there are? Well, no, that's not possible. Okay, this set of data doesn't lend itself to being able to calculate an average. So to find the mean, well, we can't do it. So we're just going to write n/a. It's not applicable. You can't find the average of colors. Okay, same thing with median. All right, I would have to put these in order from least to greatest, but is one color greater than another? I don't know how I would be able to do that and then be able to find the middle. So again, for the median, well, this sort of data doesn't lend itself to that, so I'm going to say it's not applicable. Okay, the mode, the one that shows up the most. Now that you can do. I can look at my list of colors here and figure out which one shows up the most. I've got red, orange, green, orange, blue, purple, red, orange, blue, orange. Okay, I saw a couple of reds. All right, I see a couple of blues, but orange, 1, 2, 3, I see 4 oranges in that list, which is more than the others. So the mode is going to be orange. Okay, so in this case, the best measure of central tendency, well, I was only able to figure out one of them, and it was the mode. The best measure of central tendency is the mode. And this is the first time that we've ever calculated the mode to be the best measure. And the reason why it's the best measure is because the data is non-numerical, meaning it's not numbers. If the data is non-numerical data, then we're going to have to use the mode to be the best measure. So let's go and flip back to the last page, and at the top, where we had our how to choose the best measure, well, now we can fill in for the mode. Choose the mode when the data is non-numerical. If you have a list of data that isn't numbers, then you're going to have to use the mode as the best measure. Okay, so just to reinforce this, choose the mean if the data does not have an outlier. Choose the median if the data does contain an outlier. And we're going to choose the mode as the best measure of central tendency if the data is non-numerical.